Here we'll introduce the concept of a limit. What is a limit? And we'll work through a few examples. So, as a definition, the limit as x approaches some value a of some function equals L. What does that mean? It means that as x gets closer and closer to this value, then the function approaches some value L. Okay, so it's simple as that. We need to also look if a function is discontinuous at x equals a. In other words, there's a hole in the graph close to, right where x is equal to a. Then we need to test that as x approaches a from both sides, the function approaches the same value, because if it approaches one value from the positive side, another value from the negative side, then the limit does not exist. So algebraically that's written as f, the limit as x approaches a from the negative side, or the left side of a, as we give values x, as we give the x values just to the left of a, the function must be equal to the same value as from the right hand side as x approaches a from the positive side or from the right hand side. So it may look complicated, but we'll just work through some examples and see that it's not that difficult. So if we're asked to find the limit as x approaches 2, now we write it with a little l, lim, as x approaches 2, that's like a subscript under lim. And we want to find that limit as x approaches 2. Now, from our knowledge of this is a quadratic, so it's like a parabola, and that's a continuous function. It does not have any holes in it. It is a smooth function. It's a curve. We could draw up some tables of values, and I've saved a bit of time here. So we want to know what's happening as x approaches 2 of this function. So if we put in the value 0, 1, 2, 3, 4, and we do the calculations for what is the y value or the value of the function, we've got -6 or -6, -4. We're trying to evaluate what happens at 2, 6 and 14. So we've left a bit of a gap here to see what happens, and so what I've done is just gone values either side of 2, 1.98, 1.99. And we can see that here we're getting close and closer to 0, and here we're getting bigger and bigger from 0. So it's a good chance that this is going to be equal to 0. If we were to graph it, we graph these values over here. We've got -6 for y, and when x is equal to 1, we've got -4. And it looks like the graph is going to continue. So you know, or you should know your knowledge of parabolas, that this is going to look something like that. And so it looks like that is going to approach the value 0 as x approaches 2. So this is a straightforward one. All we have to do, because it is continuous, is to substitute in the value 2. So we got 2 squared plus 2 minus 6. And we've got 4 plus 2 is 6 minus 6 is 0. So the limit as x approaches 2 is 0. Once again, this is a continuous function. We don't have to apply both sides, but you can see that as x approaches 2 from the negative side, we're getting closer and closer to 0. And as x approaches 2 from the positive side, so numbers just a bit bigger than 2, x value is a bit bigger than 2, 2.02, 2.01, we can see that as we get closer and closer to 2, we're also getting close to that y value, or the function equals 0. So there's a simple example. The next little talk I'll come back and do some more complicated ones where we've got to actually look at discontinuous functions.